Welcome to Unit 3, Lesson 2 for pairs of angles, and we are getting right into this proofs unit. So, jumping right in with this warm-up, we are going to simplify each expression. Remember, it is important to make sure you distribute to both of the things in the parentheses. So this would be 90 minus 2x minus 40. And when you combine like terms, it should be our 90 and negative 140. That would give us negative 2x plus 50. Okay. For number 2, we are going to distribute this negative 1 to all things. So the negative 1 times 3x give us negative 3x, and negative 1 times negative 10 gives us a positive 10. So when we combine our like terms, that negative 3x can stay, but 10 plus 180 would give us 190. And then last but not least, we are again distributing a negative 1. So we would have 90 minus x minus 20. And so combining the like terms, negative x stays, and then 90 minus 20 gives us a positive 70. Okay, so we are going to start with pairs of angles, and our first one are adjacent angles. And when we have adjacent angles, it is two angles that have a common vertex and a common side, but no common interior points. So you will notice with these two angles, we have angle 1 and angle 2. They are next to each other. They share this little side, and they share the vertex, but that is all they have in common. The next one is a linear pair of angles, and it's a special pair of adjacent angles, but their non-common sides are opposite rays, which to you just means that it makes a straight line. So it's actually 180 degrees for both angles. All right, so starting with angles 5 and angle 6, we would have angle 5 and angle 6. Notice with these angles, they share a vertex and they make a straight line. So this would be a linear pair. For angles 7 and 6, notice they have a common vertex, but they do not have any common sides. So this is not adjacent. Then with angle 8 and 6, we have angle 8, angle 6. They share a vertex and they make a straight line when they're put together. So that makes them a linear pair. And then with angles 5 and 7, they share a vertex. They have a common side, but they do not make a line, but that is okay because they are just adjacent to each other. They are next to each other. So for our theorem, we have the linear pair theorem, and that basically just says that the two angles added together are supplementary to each other. So you can have the measure of one angle plus the measure of the other angle equals 180 degrees. So if you notice, we could say angle 5 and 6 in this picture is a linear pair. So then we could say angle 5 plus angle 6 equals 180. Or if we wanted to use 6 and 8, measure of 6 plus angle 8 would also equal 180. So then we have our complementary and supplementary angles, which you should hopefully be familiar with. Complementary angles have a sum of 90 degrees, and supplementary angles have a sum of 180 degrees. So there are a couple memory tricks for this. Some people see the 1p in complementary. If p is 90, then the 2p's in supplementary would make it 180. Now, if maybe that's too mathy for you, or maybe that just doesn't help you, you can also, the silly way I remember is that C comes before S in the alphabet and 90 comes before 180 when you're counting. So whenever you're doing these, if you need to find the complement of an angle, then you are going to subtract its measure from 90. So you'd have 90 minus x, which, 90 minus 45 or 90 minus 60, whatever your angle measure is. If you are looking for the supplement of an angle, then you're going to subtract its measure from 180, or 180 minus x. So again, 180 minus 60 degrees if you want to find the supplement of 60 degrees. So if I want the complement of f, complement lets me know that it's 90 degrees. So I would do 90 minus 59, which gives me 31 degrees. Done. And then if I want the supplement of g, I would have 180 minus the quantity 7x plus 10. And be sure to use parentheses so that you can distribute that -1 just like you did in the warm-up. But then we would have 180 minus 7x minus 10. And then when you combine your like terms, you have 180 minus 10, which would give us 170. And then I would just keep that -7x. And personally, I like to put it in the front, so I would write -7x plus 170, but you can also write 170 minus 7x as well. So then, vertical angles are two non-adjacent angles formed by two intersecting lines. So these are angles that don't touch each other, and they are formed by two intersecting lines. So if we look at angle 1, its vertical angle would be angle 3 because it is not next to it. And then with angles 2 and 4, they would be congruent to each other because they are opposite of each other, and they are vertical angles. One way to spot vertical angles is to notice when you see an X with two lines that intersect. So we want to name some sets of vertical angles. If we start with these ones, remember you want to put kind of like directions. If I'm going from H, I need to go from H to M to L to make that angle. And that's going to be congruent to angle JMK. And then my other one is going to be angle HMJ is congruent to angle LMK. Okay. With the vertical angles theorem, we do know that vertical angles are congruent to each other, so that is why I was able to write all of these statements up above, because all of these angles are going to be congruent, or at least the pink ones will be congruent to pink and green will be congruent to green. So if we want to find the rest of these measures, and we know that angle 1 is 126 degrees, we can figure out the rest pretty easily. We know angle 1 is 126, which means angle 3 is going to be exactly the same because they are vertical angles. So angle 3 is 126 degrees. So then to get angles 2 and 4, we know that they would be supplementary to the other angles that we know. So we would just do 180 minus 126, and that would give me 54 degrees for both angle 2 and angle 4. Okay. If you liked the video, give it a like and subscribe to the channel so that you can make sure that you get notifications every time new videos are posted. If you have any questions, just comment below, and we will see you later.